Welcome to The Explainer. Today, we're going on a little journey together. We're heading into the deeply mysterious, heavily guarded layers of the sleeping mind. You know, we spend roughly one-third of our entire lives either sleeping or, let's be honest, just trying to sleep. And yet the landscapes we visit during that time, there remains some of the absolute most misunderstood phenomena in all of science. So let's just dive right in and begin our descent.
Take a look at this number right here, 95 to 99%. That massive percentage represents the portion of your dream life that you are going to completely forget. I mean, just think about that for a second. You literally spend hours every single night experiencing these vivid, incredibly emotionally charged and bizarre adventures, and your brain just throws almost all of it right out the window before your feet even hit the floor in the morning.
This level of incredible amnesia really sets the stakes for our exploration today. I mean, why would human biology devote so much energy to creating this entire alternate reality only to hide this massive chunk of our lives from us? To answer that, and to figure out how we can actually bypass this system, we need to peel back the layers of what is actually happening in your brain after you close your eyes.
Okay, layer one, the relatable bizarre. Let's look at some rapid-fire, curious science behind the weird things we all experience at night.
Now, you might be someone who says, well, I just don't dream. But the science, it tells a completely different story. Turns out, everyone over the age of 10 actually has at least 4 to 6 dreams every single night. So even if you wake up entirely convinced that your mind was completely blank, you were actually cycling through multiple different dream narratives. No way around it.
And these dreams, they don't just happen randomly. Our absolute most vivid dreams occur during REM sleep, that's rapid eye movement sleep, which cycles through our brains every 90 to 120 minutes. And this brilliantly illustrates a really crucial safety feature of the human body. During REM sleep, your body actually deliberately paralyzes most of your muscles. Why? Well, simply so you don't physically act out all the crazy things your brain is dreaming about.
Also, while we often think of dreams as these hyper-colorful, psychedelic experiences, that's not true for everyone. Did you know about 12% of people actually dream entirely in black and white? Pretty wild, right?
And there are a few more curious quirks of the sleeping brain we should talk about. During a dream, the part of your brain responsible for logic basically just shuts completely down. This means your waking life heavily hijacks your dream narrative. For instance, you only dream of faces you've actually seen before, whether that's in person or just on TV. Your sleeping position totally matters too. Sleeping face down significantly increases your chances of dreaming about being smothered or, interestingly enough, having sex dreams. And when it comes to nightmares, they aren't usually driven by fear, which is what you'd expect, right? Research actually shows they're much more likely to be driven by feelings of guilt, sadness, disgust, or confusion. Oh, and if you ever catch your dog twitching in their sleep, yep, for sure, even your pets are having dreams.
So that brings us to layer 2, waking up inside the dream. What exactly happens when the brain's circuitry misfires?
Have you ever woken up, thrown off the covers, brushed your teeth, made your bed, maybe even poured a cup of coffee, only to experience that uncanny, sinking dread of realizing you're actually still asleep? This is called a false awakening. It happens when the brain retains a certain sense of consciousness, but you are just completely wrong about being awake. It's this super eerie threshold state that blends sleep and wakefulness together, and it's often triggered when you're anticipating some sort of stressful sleep disruption.
Now contrast that eerie trap with this, the lucid dream. Fun fact, this term was actually coined way back in 1913 by a Dutch psychiatrist named Frederik van Eeden. Unlike a false awakening, where you're totally fooled by the dream, lucidity is this deeply empowering state where you become fully 100% aware that you're dreaming. And once that realization hits, you can actually gain volitional control over the dream characters, the narrative, the whole environment. It's actually a distinct, highly trainable cognitive skill.
But it is absolutely crucial to understand the difference between these threshold states. So, a false awakening is when you're dreaming but wrongly believe you're out of bed. Sleep paralysis, on the other hand, that's when you are mentally awake, but your body is still experiencing that protective REM muscle paralysis we talked about earlier. So you're basically pinned down, which is often accompanied by really terrifying hallucinations of an intruder in the room. Both are just fascinating, and yeah, sometimes terrifying, glitches in the matrix of our sleep cycles.
But when you hit a true lucid dream, your brain lights up like a highly active machine. Studies show this is triggered during REM sleep and features a massive surge in beta-1 frequency brainwaves. Those are the exact same fast brain waves associated with active, waking concentration. I mean, brain scans literally show massive activity in the dorsolateral prefrontal cortex. That's the area tied to higher cognitive functions like logic, working memory, and self-awareness. And this brilliantly illustrates the connection between mind and body. Because your eyes still move under your lids during REM, scientists can actually communicate with lucid dreamers in real time. They do this by tracking their conscious, pre-planned eye movements. How cool is that?
All right, moving on to layer 3, the sensory shift. Let's tackle a really profound question. How exactly do blind individuals construct their dreams?
Well, the answer actually depends on when a person lost their sight. For those with late blindness, meaning they lost their vision later in life, they actually retain visual imagery in their dreams, though it does gradually fade over the years. But for those with congenital blindness, meaning they were born blind, their dreams contain absolutely no visual imagery whatsoever. What's truly fascinating here is that research shows the ability to visualize in dreams is entirely independent of optical perception.
And this is what makes it so incredibly fascinating. The brain just compensates. For a congenitally blind individual, they don't just see a dream world. Instead, they step into a vividly constructed reality built entirely from intense auditory, gustatory, olfactory, and tactile sensations. They literally feel the textures of the dream, they hear the spatial layout of the environment, they taste and smell the dreamscape with a richness that sighted people rarely, if ever, actually experience.
Finally, we reach layer 4, the great erasure. Why on earth does our brain actively destroy all these incredible experiences?
The answer actually lies in our neurochemistry. As the Brain Research Bulletin points out, the brain's record button, a memory chemical called norepinephrine, which is absolutely vital for encoding new memories and maintaining waking attention, is deliberately turned down to near zero levels during REM sleep. So you're having this rich experience, but your brain flat out refuses to hit save.
But here's the kicker. It's not just a passive failure to record. It is an active deletion. Researchers have discovered specific cells in the hypothalamus called MCH neurons that become highly active during REM sleep, and their specific job? To actively suppress and erase dream memories. This neurochemical erasure isn't a glitch either. Scientists hypothesize it's actually a vital evolutionary feature. It prevents us from dangerously confusing our vivid, wildly illogical dreams with waking reality. Basically, it keeps our reality testing completely intact.
But what if you actually want to bypass that delete button? Well, you can. Dream recall is a highly trainable habit, and here is exactly how you can hack the system tonight. First, simply set a strong, conscious intention to remember your dreams right before you fall asleep. Just tell yourself you're going to remember. Second, try to wake up naturally from lighter stages of sleep, because that correlates with way better recall. Third, recognize that you only have a 30-second to 5-minute window before that memory is gone forever. And finally, when you wake up, don't write it down, just grab your phone and record your voice. Speaking is so much faster than typing, which allows you to literally beat the brain's natural memory decay curve.
So we've descended through the quirks, the lucidity, the sensory shifts, and the great erasure of the dreaming mind. Now that you're armed with the tools to bypass your brain's delete button, I'm going to leave you with this one provocative question. When you close your eyes in a few hours, what will you choose to explore tonight? Try to see your upcoming sleep cycle not just as simple rest, but as an active, untapped adventure that's just waiting to be remembered.